Okay, so in this section, we will be looking at using drawing and modifier tools that are generally used in 2D drafting, and we'll be looking at how to use them to create an orthographic representation of a three-dimensional object. So we'll be looking at the drawing tools that are in the Home tab, and we see that there's different containers as we've spoken about before. So the drawing tools that we're going to look at mainly are the line tool, the rectangle tool, the circle tool, the fillet tool, and we'll look at some of the relations or constraints. So we're actually going to use these tools to put together a drawing of a simple bracket. And as we go through creating the bracket, we'll see how we use each of the tools. So let's just identify where the tools are first and look at how the drawing container is actually accessed. So in the drawing container, as said before, are where the majority of your drawing tools are. We have the line tool, we have the rectangle tool, and we have the circle tool. If we click on any of these down arrows to the right of any of the drawing tools, we'll say extra tools come down. So we see that there's the line tool that just creates a line by its endpoints, but we also have the curve tool, the point tool, and free sketch. If we do the same thing on the rectangle tool, we see we have rectangle by center, rectangle by 2 points, rectangle by 3 points, and polygon by center. If we click on the circle, we see that we have circle by center point by 3 points, tangent circle, ellipse by center point, and ellipse by 3 points. Now to start, we just want to use the regular line, rectangle by center, and circle by tangent circle. To start, we'll start with the rectangle by center. We are in our drawing view, and we will simply start by creating a rectangle by left clicking anywhere within the working sheet. So we click and we expand out. Now the edge of the rectangle is now attached to the cursor. So anywhere we move, the upper left corner of the rectangle is attached to the cursor. Now we can manually put in the width and the height of this rectangle without having to depend on the cursor's position. To do this, we look in the dynamic toolbar and we see that width, height, and angle are now present. We call this a dynamic toolbar because, as said before, this changes with every tool that you use. So we left click, we expand our rectangle to wherever we want, and in the width toolbar, we just type 100 in the width box, press tab to go to height, we change this to 80, and for angle, we are going to use 0 degrees. So now we have our rectangle drawn. Now when we have a tool selected, if we're drawing the tool, if we have a tool selected and we're making some geometry, all we need to do is right click to release the geometry from the cursor. So in this case, where I have the rectangle attached to the cursor, if I right click, the rectangle will now be released. However, if I left click anywhere again, a new rectangle will be drawn. So the tool is still active, it's just that when we right click, we release the tool. To get rid of the tool entirely, or to make the tool inactive, we need to go to the select tool so that we have our regular cursor. But now that we've made this rectangle, we see around the rectangle we have these 8 points. These come up when we have this button selected, the relationship handles. We'll see how this comes into play in a little bit, but for right now, we'll deselect that button and make sure it's off. By default, when you're making any drawing, we want to make sure that maintain relationships, relationship handles, and relationship assistant are in this configuration so that we would only have maintain relationships being highlighted. So now we have our rectangle. Let's now create a circle to the right of that rectangle that is at the tangent to the right edge. So we'll select the tangent circle tool. Now a tangent circle will create a circle that is tangent to any edge. So what we do is we put our cursor along this right edge. Notice that the cursor has a small image to the bottom right, and it changes depending on where we are. We talked about this briefly before. These are the IntelliSketch constraints that we had talked about, and we want to make the circle tangent at the center of this rectangle. So we wait until we get to the midpoint indicator, we left click, and then we start moving outwards. You see that the circle again is attached to the cursor. So let's take it out a bit, and for the diameter of the circle we want it to be 80 millimeters. We see that that is present in the dynamic toolbar, so we select 80 and press enter. Now we pressed enter, that created the circle that we wanted. However, it hasn't positioned it. So we need to make sure that it's in the proper spot to actually create the circle. So let's start again. Tangent circle, find the center point, take it to 80, press enter, and without moving, just left click. This places the circle. Okay? So you need to left click at every point after you have entered information into the dynamic toolbar, or else your geometry will still be able to move. So now let's use the line tool and create two lines above and below the circle that is tangent to the circle and intersects the corners of the rectangle. So we click the line tool, we go to the upper right corner of the rectangle and left click once. So that's our starting point. So our line is now following our cursor. We'll now move until we see the tangent indicator, which is the curve with a dot on the top here. We left click one more, and we've now created that line. However, we see that the line tool is still following our cursor. So as said previously, just right click to release the tool, and we go to the bottom right hand corner, left click again, go towards the circle until we see the tangent indicator, left click once more. Now we don't need the line tool anymore, so we right click to release and go to select so as to deactivate the tool. Now what we want to do is we want to use the fillet tool and the chamfer tool. Now a fillet is simply a bevel or a rounding of an edge, and a chamfer is also a bevel, but rather than being round, the chamfer is a flattened edge. To use either of these tools, we go to the fillet tool, which is in the draw container, and we'll start by using a fillet. So we'll just click on the default tool. To use the fillet, essentially what we do is we click on any two edges that we want the fillet to be at, or to be between. So let's zoom in a bit. So let's left click on the upper edge and left click on the leftmost edge, and we see that now we have a curve or a constant radius fillet attached to our cursor. We want our radius to be 10 millimeters, so we can either move it to be approximately 10 millimeters, or we can type 10 millimeters into our dynamic toolbar, press enter, and we have our fillet created. So now let's make a chamfer in the bottom left hand corner. To do this, we press the down arrow beside the fillet tool and select chamfer. Now the chamfer has 3 entries rather than 1. You need to define an angle, a setback for A and a setback for B. However, to use the chamfer, you go about it the same way as the fillet, whereas you select the 2 edges that you need to create the bevel between. And now we see the angle and the setback, A and B, as we move the cursor. So A and B are basically how far up along the edge the setback is, and the angle is what is the angle created with that edge. So we want our angle to be 45 degrees, which is selected by default. So we press tab, to go to setback A. We want A to be 10 millimeters, tab again, and we want B to also be 10 millimeters. And we press enter. Now we have enter, but if we move the mouse any, we might be able to actually change where the setbacks are, and we don't want to do that. So the chamfer is not actually placed until you left click. So on left clicking, we see our chamfer. So now we have this as our drawing. Now let's actually turn back on the relationship handles. So we left click here and we see that we have the handles present. We want to actually define some relationships so that we can make sure that the geometry we created won't change if we change anything external to the geometry. So what we'll do is we'll use the parallel constraint and make sure that the top and the bottom edges are always going to be parallel to each other. So we left click here, we left click here, and we left click there. Now we see that the handles have changed. We see we have this little parallel or equal sign on each edge. That ensures that our edges are now parallel with each other. So we also want these two edges to be parallel. So we left click here and we left click there. Those are now also parallel. Now let's select the perpendicular constraint. And we want to make sure that this line is always 90 degrees to this line, or is always perpendicular. So we select, we left click here, and we left click here. Now we see the little box that we generally denote as being a 90-degree angle or a right angle showing up. So we've defined those two. Let's also make sure that these lines are always tangent to this circle. So we go to the tangent constraint, left click here, and we select a line, this line, and we make sure that it's tangent to that circle. We see a little circle showing up on our point. Well, let's do the same thing here. Make sure it's tangent to that circle. Right, so we've defined the parallel relationship here, here. We've defined the tangent relationship here, and the perpendicular relationship here. Now, let's do one more, and let's look at how the order of constraints are actually placed. Let's create a new circle by center point. Let's create it anywhere out here. We want a diameter of 20 millimeters. So we'll enter 20, enter. Now, after we've done this, we see that a copy of the same circle with a diameter of 20 still is connected to our cursor. Just right click to deselect that. Now what we want is we want this circle to be in the exact center and concentric to this larger circle. So what we do is we'll select the concentric constraint. Now with any of the constraints, it's very important to remember the order in which you do the constraint or do the relationship. What happens is that any geometry that is selected first will adhere to the relationship with the second. Let's see what that means. Let us take this circle as our first circle, and let us select this circle as our second. Notice that this circle has moved and has, in that case, elongated everything connected to that circle. But that's not what we want. Let's see what happens when we do it the other way around. So we go to our constraint relationship, our concentric relationship, sorry. We select the small circle first, and the second circle, the larger circle, is what we select next. Now we see that the smaller circle has now been constrained to the center of the larger circle. So we've now created this relationship with the large circle. So it's very important to remember with the constraints, with the relationships, you want to select what you want to adhere to the constraints of another part of geometry first, and then select the other part of the geometry second. So we've done this. Let's now go ahead and place some dimensions in. Now, since we're not going to do any more relationships here, we can turn off the relationship handles again. And we can go to our select tool just to deselect from our active tools. Now, there's two dimensioning tools we're going to use, the smart dimension and the distance between 2 points. So smart dimension can be used for just about anything. It automatically detects what a dimension is, and it places the dimension depending on whether it's an edge or a corner or a radius or diameter. So here we just clicked on this edge and we see that it's connected to our cursor, 90 millimeters. So we left click again to place it, and we see a dialog box come in. Now this we'll talk about a little bit more later on, but this is the difference between what's called a driven and a driving dimension. We are going to just press enter on this to select 90, And we'll see in a little bit the difference that driving and driven dimensions present. But let's just dimension some more things. Let's dimension here, this corner, 14.14 millimeters. Press enter. Let's also mention this edge here, 60 millimeters. Left click, radius of 10. Left click, diameter of 80. And left click, diameter of 20. Let's use a distance between tool, and now let's say that the distance between this point here, this end point, we see the end point indicator come up, and sorry, let's do that again. The distance between here and this end right here is 90 millimeters. We see this is green. Now this is what's called the driven dimension. Any dimension that shows up being green is driven. A lot of the times when you over-define an object, or you essentially define the same place more than once, or define everything around that object so that that particular dimension is not needed, you end up with a driven or an over-defined situation. So in this case, we don't need that 90 because it's placed, so we'll get rid of that. And now we have our dimensions here, and this should be good. Now let's clean this bracket up. So how do we clean things up? We use the trim tool. The trim tool, or the power trim, essentially reduces lines or any geometry at all that is in the path of a dragged component. So let's select the trim tool, and all we do is we left click and we drag across the geometry we want to delete. So I'll left click here. You see there's a line following the mouse, the cursor. I release left click, and all the geometry that I crossed over will be deleted. So let's say we wanted to delete this line. I would just left click, drag through it, and it deletes it. But we don't want to delete that line, so we'll keep that. Right. So now we have this. We have our bracket. Now our bracket is outlined in all visible lines, but we can actually in Solid Edge use different lines and different line styles. Let's select the line tool here for a second and look at the dynamic toolbar. We see that we have line color, we have line type, line width, the line itself, and an arc. We have a drop-down menu which defines a line style. Now there's a few default selections, and by default a line is visible. But remember that when we have internal geometry, we use dashed or hidden lines. So let's, from the drop-down menu, select the hidden line. And let's draw a hidden line straight down from this edge to the bottom here. We see the intersect indicator come up from our IntelliSketch. Left click again, we see we now have a line. Right click to deactivate the tool, or to release the tool, sorry. And we have a line that is now dashed. Let's again create another line here, but in this time let's stop it about halfway. Release the tool. If we have a line that can be extended to another intersection or the next perpendicular line, instead of having to draw the line all the way, we can actually use the extend to next tool. What this does is basically extends a line to the next closest intersection. So let's click on that, and let's click on our line. So you see, if I put the cursor over the line, it basically shows you a preview of the extension. So I put it over my line, left click, and the line's complete for us automatically. It's a productivity tool, but not always necessary. So now let's put some dimensions in and look at how driving and driven dimensions actually come into play. So let's say we want the distance between these two lines to be 20 millimeters. That was close, it was 29.91, but let's put 20 millimeters. So now the distance between these two is 20 millimeters. The fact that I entered the data for 20 means that the distance between these two lines is now a driving dimension, meaning that anything that affects any one of these lines will affect the other by maintaining 20 millimeters of distance between the two. Let's see what I mean by that. Let's say now that we want this line to be a certain distance away from this edge. Let's now take our distance between, and let's find the distance between this edge here. Instead of 35, let's change that to 46. Oh, I'm sorry, wrong, using the numpad. 46, and I'm going to press enter. Now notice that both of the lines moved, maintaining the space of 20, and now they maintain the space of 46 between this edge. Now why is that? That's because this line here and this line here are actually defined in their distance. Let's see what happens if I took away these outer dimensions and still try to do 46 there. So let's delete this. So I right click on this dimension to delete, and right click on this dimension to delete, and let's right on this just to be safe to delete. Let's say now that I want to change this dimension. All I do is left click on it until the box appears. Now let me change this to 46 and see what happens. Well, it decided to go ahead and do that for me. Let's delete these as well, just to be safe, to get rid of all of our dimensions that may be driving then. And let's just delete this as well for the time being. And let's create a new dimension between here and here. And we want this to be 46. There we go. Now see, essentially what's happened is that it's created a dimension of 46 by changing the geometry around these two lines. Whereas before, when we had all these defined dimensions, when we were to place 46 as our dimension, it only changed the two lines here in terms of moving them while keeping this 20 millimeter space between. Now that's the difference between driving and driven dimensions in a very brief summary, but we'll see again in more depth the difference between driving and driven dimensions. But here we are, we have this bracket, we have it dimensioned. We will look into, or you should at this point in time know the proper dimensioning techniques to tell whether or not this bracket is over, under defined, or fully defined. But when we look into dimensioning more, we'll see how to define and to use these properties. Okay, and that's it.